What a great time to be alive. We're living longer than ever thanks to the amazing scientific discoveries and innovations that improve our quality of life. So while science is, stretching the human lifespan ever longer, the number of diseases related to aging is also increasing, such as Alzheimer's disease. Even though Alzheimer's has long been known to be a disease more than 100 years ago, we still haven't come up with a cure to stop the disease. Alzheimer's is a neurodegenerative disease believed to be caused by the accumulation of protein fibers outside of neurons, the cells in our brain. It's believed that these sticky protein fibers, which is made up of amyloid beta, accumulates over time as we age. Now, at the cell level, making and destroying proteins is completely normal, and it's actually important to keeping our bodies healthy. So the prevailing hypothesis is this: as we age, our neurons gradually lose the ability to produce enzymes that naturally degrade amyloid beta. If this hypothesis is true, then therapy should focus on preventing, if not reducing, the accumulation of amyloid beta. So one such therapy is using antibodies. Antibodies are proteins that guide our immune cells to find, target, and eliminate foreign invaders. So scientists have developed antibodies that target amyloid beta in the hope that we use our own immune cells to degrade amyloid beta. However, recent clinical trials have been very underwhelming, in which some patients have experienced severe brain swelling as a side effect to the immune response. So why not just directly degrade amyloid beta by, let's say, making more of the enzymes that neurons already make? Well, that's a great idea, but there's one major issue. That is, these enzymes are not specific enough for amyloid beta. They also degrade other proteins in the neurons. So instead, our research group decided to go back to nature. In this case, we looked for new enzymes that could be more specific to amyloid beta and will degrade them and no other protein. So it turns out, using bioinformatics, we found dozens of candidate enzymes that are from a family of viruses that actually infect flowers. So using structural computer simulations to determine the structure of these viral enzymes, compare that to the structure of amyloid beta, we narrowed down our list of enzymes that can potentially bind to amyloid beta. Now, armed with this structural information, we are now synthesizing, testing, and further mutating these enzymes in the lab in the hopes that we could improve their specificity as well as their ability to efficiently degrade amyloid beta. In the long term, our lab hopes to deliver these engineered enzymes to degrade amyloid beta in the brain as a promising therapy for Alzheimer's disease. Thank you.